Part 3 of Exam 2. Part 3 asks us to draw a diagram for a 3x8 decoder, an 8x1 MUX, and use 3 state buffers. So the way I chose to approach this problem was to create a truth table. So in my truth table I have X, Y, and Z here, and each one of these values is then fed into D, and D has to equate to all these, 0, 0, 0, so there's going to be a whole bunch of NOT gates coming through into D to turn this true. Now, next we have the 7 lines for the MUX, which come in, and they all pass into our tri-state gates, which is this column here. And if that's true, then that goes into the OR, and it produces an output value for Y. So, we have the decoder here, we have the MUX lines here, and then we have our tri-state gates here. So, let's take a look at what that looks like in circuit verse. In circuit verse, we have our X, Y, and Z here, and then we have our MUX lines here, and as you can see we have a row of our AND gates, and then we have a row of our tri-state gates, all being ORed into an output. So let's go ahead and set this to 0. And we can see that all these lines are green. We have a green line going across to our tri-state gate, which turns this LED red and our output red. Now, if we turn this off, if we have no input, then we have obviously no output. So if we go to 001, which is this bit, we have no input. Now we have an input, no input. And we can do this for all of them real quick. So there's 10, 11, and we'll set that to 0 and go to 100 and 101. And there's 110 and then 111. And again, if we switch the bit on and off, we have input. Hope you learned something. Hope you're having a good day. Take care. Bye-bye.